Okay, hello guys. This video will explain to you how do we quantify the magnitude of our resultant hydrostatic resultant force on an inclined surface. And after that, we will also look into the method how to find the location of your resultant force if it's acting on an inclined plane surface. To find the magnitude of your hydrostatic resultant force on an inclined surface, we still use the equation of F resultant is equal to P average times with A. So we expand the equation, so it becomes gamma HCE or rho G HCA, where the HC is distance to centroid. And your E must always taken from the surface of the inclined plane, surface of the object, which is in contact with fluid. In any cases, we always ignore the P atmospheric inside our F resultant calculation because the P atmospheric acting on both sides, from this side and also from this side with the same magnitude, so it can be cancelled out. That's why in most situation, the hydrostatic or the total force acting on your plate, it can be a vertical plate or horizontal plate or an inclined plate like this. We neglect the P atmospheric when we want to find the total hydrostatic force acting on that surface. Okay, so what does it mean by that center? If you would take this equation, okay, you have a plate submerged under a liquid. Above here you have air, which give you the PATM, and at the same time here you have the P because of the fluid. Okay, so the total P, the P average that is acting on that surface is actually equal to P of your fluid plus with the P ATM. So therefore, when you want to find your force resultant, the total force resultant acting on your surface, it's equal to P of your fluid plus P of the ATM times with the A. Okay, in which this PATM, either it's given in the question or you find from a barometer, or given or barometer, or you use the standard value, which is 101.31 kilopascal. Okay, meanwhile for this one is the one that you get it from here. Okay, so when we come back to the concept where for a hydrostatic force, okay, we always neglect the existence of the P atmosphere because the magnitude of the force can be cancelled out from each side of your object. So this part become 0. Next, we look at the location of your resultant force. Okay, for the location of your resultant force, it started off with this equation okay, in which you have to be very careful with your YP and YC. YC always to the centroid of your object, okay, which for a rectangle, half of your height. If it's a triangle, then 1/3 of the height. Okay, if the circle, then so half of the diameter. That is the centroid, the distance from the centroid to the water surface. If you are dealing with horizontal and vertical, it's very easy. So you know that your YC is equal to HC if it's a vertical. But for an inclined surface, you need to be very careful with this definition, okay, in which your YC is being defined as the distance from your centroid to the water surface. This distance is called HC. Okay, so next we have the YP for a vertical surface. We will use this equation, and in our previous slide we have covered that in most situations we will ignore the existence of our atmospheric pressure, so this part become 0, so leaving you only the YP equal to YC plus second moment of inertia YCA. Okay, this one. This second moment of inertia, second moment of area, or area moment of inertia, can be referred to this table. Okay, depending on your shape, you find the equation for your centroidal moments of inertia from this table. Okay, we take one case to show example how do you use the equation. Consider that you have a dam holding water. Okay, the dam angle, wall angle is 60 degree, and it's the dam is fully impounded with water. Okay, so you water, and then the height, the depth of the dam is 4.7 meter. Quite shallow dam. Okay, the question is find the hydrostatic resultant force exerted by the wall. Okay, and this wall is the width is 3.5 meter. Okay, find the hydrostatic resultant force exerted by the wall. So we go with the F resultant equal to P average times with the A. And here it says that the hydrostatic resultant force, so you can ignore the P above here. We are looking only for the force due to the hydrostatic. Okay, so equal to gamma HC A 9.81 kilonewton per meter cube times with the HC. Okay, how do we find our HC? This is 4.7. Okay, that your centroid is somewhere here. Okay, so your HC is 4.7 divided by 2. 4.7 over 2. And then you need to find the A. A is defined as the surface area in contact with the water. So from the diagram, you know that you need to find the length here, okay, times with 3.5. Okay, so how to find that? That length is not given, but you are given this 4.7, and the angle here is 30 degree. So we assume this is y. Okay, so your y is equal to 4.7 sine 60. Here is 60. Okay, so substitute that into our equation here. You will have 4.7 sine 60 times with the width. Okay, so you will get 437.9 kilonewton. That is the hydrostatic force acting on your wall. Okay, next we extend the question. Find the location of the resultant force, the hydrostatic resultant force. So we can start with this equation, this one. Okay, we start from this equation, but because we are looking for the hydrostatic, the location because of the hydrostatic, so we ignore this one. Okay, leaving you only this part. So from there, you have your yp equal to yc plus the moment of inertia yc a. Okay. Okay, so where do we get a yc? Here we have a y there, so yc is half of this. Okay, this one is equivalent to 5.43, so yc is equal to 5.43 divided by 2, 43 over 2 plus with the 3.5. Okay, so with that we will get your location of the resultant force is 3.6 meter from the water surface. Okay, actually there is another rule of thumb which may be useful for you to know, but in order for you to use this, my advice is be very careful with your question. Okay, the rule of thumb says that if you have a fully submerged plane surface, and then it's a rectangular object. Okay, then the yp of your resultant force is always acting 2/3 of the height. In this case is in this question, because our height refer to this height. Okay, so equal to 2y over 3, which is also 3.6 meter from the water surface. Okay, this is the rule of thumb which may be useful, but be very careful when you want to use this equation. Okay, with that we are done with the inclined hydrostatic force acting on an inclined plane surface. See you in our next video. Bye bye.